me here. I want to thank you all, and thanks our mayor, Jean-Luc Moudin, and his team, for giving me a chance to talk about mobility, but not mobility on Earth, mobility on Mars. Mars is a very interesting planet. We call it a two-phase planet in the sense that Mars today is dry, cold, and I would say very boring. But in the past, approximately 4 billion years ago, that planet was covered by water, liquid water, and ice. And at that time, another planet, Earth, was experiencing something incredible, life. At the same time, life appeared on Earth. So, does it appear also on Mars? That's our question. Were there ever life on Mars? Well, for that, to answer that question, we've built over time an amazing space program called the Mars Program. This is what it is now, and it's very impressive. Today, we have 12 missions around Mars or on Mars. We have 8 orbiters that are going around Mars every day in a few hours. And on the surface, we have 1 lander for the inside and 3 rovers. And I'm going to talk about these rovers. This is really what is mobility on Mars. Well, the most ancient one is Curiosity. You can see it here. Has been on Mars for nearly 10 years, actually 10 years minus 2 months. We've been very lucky here in Toulouse to build the top of the mast called Can-Can. This rover has been driven 27 kilometers in 10 years. I'm sorry, that's not much. People are laughing about that. They say it's less than 10 meters a day. Well, we're not big fans of distance or speed. Well, one day we've done 140 meters. We were so happy. But usually we do a couple of meters per day. And we go so slow. Well, I should rephrase that. We have covered 350 million kilometers plus 27. It's pretty far away. And it's very hard to drive such a car on Mars. It requires approximately 50 people every day to drive it. It's a very smart robot, but it's a very complex one. You can see here it has 6 wheels. There are, of course, electrical engines on board, driven by plutonium. Well, don't use that on Earth, okay? It's fine for Mars. It's great. It's not any bigger than that, and that gives you enough energy for 10 years or more. But it's only for Mars. And that energy is enough to drive it days or night, winter, summer, of course, and also give it a chance to turn the mast or to operate the arm. Well, actually, you don't see the arm here because it's a selfie. We do it like this, just like you do it, and then we're stitching together all the images, and that's our Martian selfie. Well, Curiosity made many different discoveries. One of them, the most important one to us, is to prove that Mars in the past was an habitable world, with everything, liquid water and plus many other things, chemistry, that life could develop on Mars. But we don't know if it did, and that's the topic of another experiment I'm going to talk about. Well, just like on Earth, we have to be careful with our car. And look at what we did. We don't call that a flat tire, but we've been pretty bad with the wheels. There was a design problem, and actually the rocks on Mars are very sharp because they result from the interaction of the wind with these different rocks. They're sculptured by the wind, and that's the cause of these holes into the wheel. So we have to be very careful. We like to drive on sand, but we don't want to get stuck. We'd like to drive on rocks, but we have to be careful. So it's very hard. The mobility on Mars, I should say, is very hard, but it's very interesting. As of course, there are no roads, so each time we drive, we define the road. Okay, well, that's one of the ones we have for 10 years. But very recently, we had a chance to have 2 new ones. One is Zhurong. Zhurong is from China, And that's an amazing accomplishment because it's the first time ever that China is going to Mars. And with the same mission, they've done an orbiter, a lander, landing platform, you can see on the right, and a rover. We have been here from Toulouse contributing to this rover, so it's another collaborating project. Our friend from China have been driving 1.5 kilometers in the last year, landed a year ago. And look at by the way, this is a real image. It's another selfie, but they've done something funny. They dropped the camera, they went back and said, hi, that's what you get here. This is good science too. It's an interesting landing site. It's approximately actually this size. It's a 300 kilo kind of rover. But probably the most powerful one now, and you might have heard about it, it's Perseverance. Perseverance, that is one. Okay, honestly, this is half scale. Okay, so multiply it by 2. Okay, bigger, whole direction, volume, it's a factor 8. It's a big car. Okay, it's a 1.1 ton car, 6 wells, same thing, mast, and we've been very lucky in Toulouse to build that part again. An arm, 3 antennas, plutonium at the back here, make it should last for long. And the goal of this mission is to search for traces of life, because we said it was an habitable world. Why don't we search for traces of life? Here we are. Well, we're landing in a place called Octavia, Butler landing site. We wanted to go on top of left, where we have a delta, because we think we know now we are at the bottom of an ancient lake, and we'd like to go on the edge of the lake where the water was flowing, where there are a lot of sediments. Well, we couldn't go straight. There are dunes, and we cannot cross, so we decided to go south, go around and turn back, and we drove as fast as we could, and we did very well. In 450 sols, the sol is a day on Mars, 24 hours and 37 minutes, we drove nearly 12 kilometers. That's quite an achievement for us. So here we are now. We've arrived last month at a place called Three Forks. This is where we're going to collect samples. But there's something I want to say, that this rover, Perseverance, was built from curiosity. You could almost say print to print. It's so close because you want to save money, and if it works, why would you do a different one? We call that heritage, and heritage is what we do in space. If it works, use it again. But sometimes you say, I want to do innovation, a great innovation, take risk. And this is what we did with Ingenuity. Ingenuity is our drone. It's only 2 kilos, so it's very light, mass. It's probably this side, and it's rotating so fast, 4 times faster than a helicopter, and it can cover quite some ground. It has done so far 28 flights, approximately 7 kilometers, and was able to cross places where we cannot drive. So driving is good, flying sometimes is better. And we did it, and it's working so well. Well, this rover, Perseverance, you have it on the left here, its goal, searching for life, is to do that in situ, but also to collect samples. So what we're doing, we collect pieces of rocks and soils, and we keep them with us. And after 3 years, we're going to drop them on the ground. After 6 years, we're going to drop a second set. And then we're done. We are finished with our mission. I'm sure we find other things to do, but the primary mission, and then we're asking NASA, and this is a NASA rover in collaboration with ESA, the European Space Agency, to go and get these samples. So a fetch rover, or maybe an helicopter, we're not sure yet, is going to land nearby, collect the samples, bring them to a rocket. We never had a rocket on Mars before. We only do one-way trip. This time we want to do a round trip. So we're going to put these samples into this Mars ascent vehicle. It's going to be put straight up, and then it's going to launch from Mars It's a small rocket, has enough energy to go in orbit and put the samples on orbit. And then we have another one built by, actually mostly from Toulouse, by ESA, is going to capture the samples and bring them back to Earth. So someone was talking about time scale. Yes, we do a long time scale too. In 2033, 12 years from now, 11 years from now exactly, we'll have our samples from Mars, approximately 300 grams of rocks. And with that, we will be able to tell you if there was ever life on Mars. So this is what we're doing now with these rovers, exploring the diversity of Mars. While we've been landing on Mars, driving, flying, but we've never walked on Mars, actually. And that's maybe the next and last adventure for us, is having astronauts on the surface of Mars. We have to take that decision altogether. It's going to require a lot of money first, a lot of intelligence, a lot of development, and of course some political decisions to do it. But we're getting ready to do that. Time scale, I would say 30 years, 40 years, well, maybe 50. I don't know. No, not sure. There's so much to do to be ready, but I'm sure one day we'll do it. Thank you.